Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The heat of combustion of cycloalkane stereoisomers reflects their relative thermodynamic stability. The more stable, lower energy the isomer, the less heat it releases upon combustion. Smallest heat of combustion is equal to most stable isomer. Moving on to the next step. Identify the compound. All four options are stereoisomers of a trisubstituted cyclohexane bearing a CH3 group, a CH3 group, H3C, and a CH3, 3-tert-butyl group on the ring. The substituents are at positions 1, 2, or 3, and 4. Moving on to the next step. Determine the most stable conformer. In cyclohexane, stability is maximized when bulky groups occupy equatorial positions. The tert-butyl group has a very strong preference for the equatorial position due to its large size. To minimize total steric strain, 1,3 diaxial interactions, the isomer that allows all, or the most, substituents, especially the bulkiest ones, to be equatorial is most stable. And for the final step, analyze each stereoisomer's ability to place substituents equatorially. Option C has the stereochemistry such that when the tert-butyl group is equatorial, both methyl groups can also adopt equatorial positions. Specifically, the configuration in C corresponds to all three substituents being equatorial in the most stable chair conformation. This is the all-equatorial arrangement. Options A, B, and D have configurations that force at least one substituent, especially a methyl or tert-butyl, into an axial position in every chair conformation, resulting in higher strain energy. Conclude stability order. The isomer in C, with all substituents equatorial, has the lowest potential energy, highest thermodynamic stability. Therefore, it releases the least energy upon combustion, giving the smallest heat of combustion. Why other options fail? A, B, and D each have at least one substituent forced axial regardless of ring flip, leading to greater 1,3 diaxial strain and higher ground state energy, hence larger heats of combustion. Therefore, the correct answer is C. Therefore, the correct answer is option C.